Okay, so we have a question. Tool workers are subject to work-related injuries. One disorder caused by strain to the hands and wrists is called carpal tunnel syndrome and is estimated to cost employers and insurers an average of $30,000 per injured worker. Suppose these costs are normally distributed. 1. State the variable and its units. 2. If 90.8% of costs are more than $7,000, find the value of the standard deviation to the nearest dollar. Well, okay, we'll just get A out of the way, or number 1. State the variable and its units. Well, it's an insurance claim. Dollars per worker or per injured worker. Oh Jesus. In dollars per worker. Sorry, I'm sick right now. So I can't really talk. I don't know why I'm doing this. Number 2. This is the fun one. 90.8% of costs are more than $7,000. Find the value of the standard deviation to the nearest dollar. Okay, so let's just go through the givens. We're given the average is 30K. The standard deviation is unknown. And X is 7,000. We want to find the P of X is greater than 7,000. And we're told that that equals 90.8%. So that's 90.8% just in decimals. Okay, so next, what are we going to figure out? If we know that the probability of X is greater than 7,000, it equals 90.8%. The complement will give us the rest. Of the probability density function area, which I'll see if we can draw. So 30,000. Oh, sorry. So if you compute this, you get 0.092. And then if you want to draw underneath, you get mu, which is 0. And trace this down. That is your standard deviation. And we know that from And that from the rest is 0.092. So we want to find the standard deviation. But what would help is that if we had, so we know this, and we know this, that equals 1. What we need to find is this area here, or at least the z-score that correlates with that area there to find the standard deviation. How do you go about doing that? Well, you take your 0.5 on either side, and we know that 0.5 minus the 0.092 will equal 0.408, which is this area in there. And that's good. So, next we get up our z-score table, and we look for the area about that mean of 0.408. And so 0.409, 0.408. That is it there. And that corresponds to, use a highlighter, 1.3, and you go up 0.3. So 1.33 is that standard deviation there. And now, if we know our Z formula, which rearranging that to solve for the standard deviation. Okay, I'm not doing the wrong one. I'm sick. I've been studying since, well, 7:30 this morning. I mean, I had 2 assessments. Anyway, that doesn't matter. Equals, yeah, x minus over z. And so if you want to find the standard deviation, you're going to have 7,000 minus 30,000 divided by your z-score, 1.33. I didn't write that down anywhere. Plugging that into a calculator, you end up with 17,293. 0.233, but I'll round it down. And that is a kind of cool trick. To calculate the standard deviation. Draw the graph in terms of x, and then it goes through a transformation down to a standardized form known as the standardized distribution table or function, PDF, whatever, probability density function. And that equates the mean to the average and standard deviation of 0. And then along this axis is the standard deviations of where the value falls, which is your probability. Because it sums to 1. I'll put that in brackets. So that A plus B equals 1.